You've got a well-framed problem and a metric. Now, before we train a single model, we explore the data. Good practitioners always look before they leap. Why bother? 3 reasons. Exploring catches problems, missing values, impossible entries, outliers. It reveals signal, which features actually move with default. And it builds the intuition you'll need later to tell a good model from a broken one. Start with a single feature, the applicant's credit score. If we bin every applicant by score and count them, we get this histogram. Most people cluster in the middle, with fewer at the extremes, a fairly normal spread. Now the interesting part. Let's color the applicants who defaulted red. See where they land? The red piles up on the left, the low score side. Low credit scores default more. Our very first feature carries real signal. We can make that precise. Split applicants into thirds by credit score, and compute the default rate in each. The lowest third defaults 36% of the time. The middle, 19%. The top third, just 14%. The worst third defaults more than twice as often as the best. The single strongest signal, though, is debt to income, the loan size divided by income, a measure of how stretched a borrower is. Among people who defaulted, it averages 0.53. Among those who repaid, just 0.31. Borrowers who bite off more relative to their income default far more. Categories carry signal too. Split by housing. Homeowners default 20% of the time, renters 26%. Renting is a modest but real risk marker. We can rank every feature by how strongly it correlates with default. Debt to income leads at plus 0.41. Income and credit score follow, both negative. More of them means less risk. Loan amount, employment, and the rest trail behind. This ranking tells us where the predictive power lives. One feature deserves a flag. Income is among the strongest predictors here. But income also differs systematically across demographic groups. A model that leans hard on income may end up treating those groups unequally, even without ever seeing the group label. Remember this, we'll confront it head-on in the fairness lesson. Exploration isn't only about signal, it's about plumbing. Always check, are there missing values? Impossible entries, like an age of 200? Outliers that could distort a model? Duplicated rows? Our dataset is clean, but you check every time. To recap, look at your data before modeling it. Here, credit score, debt to income, and housing all drive default. Flag predictive but sensitive features early. And check the plumbing, missing values, ranges, outliers. Next, we split the data and build an honest baseline.